LeetCode Problem 682, Baseball Game. You're keeping the score of a baseball game with strange rules. At the beginning of the game you start with an empty record. You are given a list of string operations where operations I is the ith operation you must apply to the record, and if one of the following: an integer x, record a new score of x, plus, record a new score that is the sum of the previous two scores, D, record a new score that is double of the previous score, and C, invalidate the previous score, removing it from the record. Return the sum of all of the scores on the record after applying the operations. The test cases are generated such that all answers and all immediate calculations fit a 32-bit integer and that all operations are valid. The approach that we're taking is the stack data structure approach. It has a time complexity of O of n and a space complexity of O of m, and it's the optimal solution to this problem. Now let's walk through the example. We're given ops is equal to 5, 2, c, d and plus. Step 1. Create an empty stack. Step 2. Loop over ops applying the following logic. If the operation is plus, sum the score of the previous two records, and this can be achieved like so. If operation is D, add the new score, double the previous. If the operation is C, remove the previous record from the stack. Else, convert the value to an int and add it to the stack. Step 3. Sum all of the values of the stack. So let's start. So operation is equal to 5. So this if condition is not true. Operation is not equal to plus. Operation is not equal to D. Operation is not equal to C. So pass operation, which is 5, and add 5 to the stack. Now let's go to the next operation, which is 2. 2 is not equal to plus, so we'll skip that. 2 is not equal to D, so let's skip that. 2 doesn't equal C, we'll skip that. Pass the 2, and then push it to the stack. Now we'll go to the next operation, which is C. C is not equal to plus, so we skip that. C does not equal D, so we skip this. C does equal C, so what we want to do now is we want to pop the stack, removing the 2 from the stack. Now the next operation is the D, which does not equal plus, so we skip that. D does equal D, so what we want to do now is we want to take the top item of the stack, times it by 2, so 5 times 2 is 10, and push that to the stack. Now the final operation, which is a plus, so we want to go into here, so we pop the stack and we'll store 10 against V1. We then pop the stack again and we'll store the 5 next to V2. Then we want to push V2, which is 5, back onto the stack. We'll do the same with V1, so push 10 back onto the stack. And then we want to push 5 plus 10 back onto the stack, so we push 15 onto the stack. Then we come down and we declare a sum equal to 0, and then while the stack is not empty, do sum plus stack pop, so sum plus 15 plus 10 plus 5 equals 30. And then step 4, return the sum of 30. And that is exactly what we wanted. Well, thank you very much for watching this video, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. LeetCode Problem 682, baseball game, in JavaScript. You are keeping the score for a baseball game with strange rules. At the beginning of the game, you start with an empty record. You are given a list of strings, operations, where operations I is the ith operation you must apply to the record and is one of the following. An integer x, record a new score of x, plus record a new score that is the sum of the previous two scores. D, record a new score that is the double of the previous score. C, invalidate the previous score, removing it from the record. Return the sum of all of the scores on the record after applying all the operations. The test cases are generated such that the answer and all the immediate calculations fit in a 32-bit integer, and that all operations are valid. So let's look at example 1. So what I'm going to do is I'm just going to sort of walk through it with you. So we know that when you're given an integer of x, we just record it as an int. So let's sort of get into it. So what we've got is ops is equal to 5, 2, c, d, and plus. So when we're given a 5, that's obviously an integer of x, so we'll put 5. Then we're given 2, so we'll record the 2. Then we were given c, which is invalidate the previous score, which we can see was 2, so let's get rid of that. Then we're given d, which is record a new score that's double the previous score. We can see the previous score is 5, so let's add double 5, which is 10. Then we go to plus, and plus is record a new score that is the sum of the previous two scores. We can see that the sum of the previous two is 5 plus 10, which is 15. And we then get to the end of the input processing. And then what we need to do is we just need to sum all of the scores on the record. So to do that, we basically just add 5 to 10, which is 15, plus 15, which is 30, giving us an answer of 30, which is exactly what the output is expecting. Cool. Now let's have a look at example 2. So in example 2, we can see, again, we've got a longer operation list. And in here, something to just note is that we can get negative scores. So we need to make sure that our solution can handle that. And you can also see here that we are given operations one after the other, so it's not necessarily number, operation, number. It can be number, 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 operation, etc. So just to keep that in mind. In this scenario, example 3, we see another sort of unique case, which is where we're given a string that converts to an integer. We then cancel it, so we remove it from the record, and you can see that in that scenario, the score should return 0. So we need to make sure that when we have a scenario where we perhaps have no inputs, we need to still return a sum of 0. Another edge case that sort of comes to my mind here is if we were, say, we only got one record and it was -2. Is that an acceptable sum for the game? Can we have negative sums at the end? That'd be something that I'd want to clarify with an interviewer. And another edge case again is where we get 0, so the output's going to be 0. And then the edge case again where we've got letter operations in sequence as well as multiple numbers in sequence. So we just need to make sure that we keep that in mind when we implement our solution. Now let's get into it. So the first thing that we're going to do is we're going to declare a stack, which we're going to use to basically keep track of the inputs or the operations, should I say, in their order that they go in. So we'll say let's stack equal this. And then now that we've got the stack, we want to then loop over all of the operations. So let I equal 0, I is less than operations dot length, I plus plus. And now that we are looping through, what we want to do is we want to check if the operation So if the operation, or the current operation should I say, equals, so we've got a few scenarios here. We want to check if it equals plus, we want to check if it equals D, we want to check if it equals C, and if it doesn't equal any of these three, then we just want to convert the string X into an integer and store it in our stack. So we'll get to doing plus first. So if the current operation is equal to plus, in fact what I'll do is, to speed me up, I will 2, 3, so 1, 2, 3, and then else, so else if, nice. So if it's equal to plus, then what do we want to do? We want to record a new score that is the sum of the previous two scores. So let's say let's score 1, or we'll call it v1 for value 1. So let v1 equal stack.pop, let v2 equal stack.pop. Then we want to push these back onto the stack. So we'll do stack.push v2, stack.push v1, and then we want to push to the stack.push the sum of v1 plus v2, so v1 plus v2. And that should handle this scenario. So record a new score that's the sum of the previous two. So we've got the previous two, we sum them here, we add it to the scorecard, or the stack. So the next one we want to handle is where the operation is equal to D. So in that scenario, we want to record a new score that's double the previous score. So to do this, we want to stack.push, and we just want to look at the top of the stack, or the peak of the stack. So to do that in JavaScript, we want to take stack, and then we take stack.length -1. We want to push the top of the stack multiplied by 2 to the stack. Cool. Then if it is equal to C, we want to invalidate the previous score and remove it from the record. So this is nice and easy. So put C in here. All we want to do is a stack.pop, taking it off the stack and getting rid of it. And then else, if none of these conditions are true, then we've been given an integer of X. So what we want to do is we want to do stack.push, and then pass int, because we're operations I is a string. So we convert the string to an integer and we push it to the stack. Excellent. So what we've done now is we've populated the stack, and all we need to do is sum the values within the stack. So to do that, we'll use a while loop. So say while stack.length is greater than 0. We'll have it put a sum to keep track of the sum. So let sum equals 0, and then we'll say sum equals sum plus stack.pop. So this will sum up all of the numbers that exist in the stack, and then finally we just want to return the sum. We'll run that, see if it works. It does. Now let's see if it passes the test cases. Excellent, it passes the test cases. So we can see that it beats 73.48% in terms of runtime, and it beats 83.66% in terms of memory. I can tell you that the runtime complexity of the solution is O of n, and the space complexity of the solution is also O of n. It's the optimal solution to this problem, and I hope that this has clarified it for you. If you like the video, please click like, and if you'd like to see future videos, hit the notification icon. If you could please click subscribe, that's going to hugely help me and the channel out, and it's going to help to get my videos out to a wider audience. Thank you very much for watching, and I hope that this has helped you a lot.